Let's revisit some of what we talked about in previous videos and marry some of these topics together. We've discussed IP address formatting. We've talked about how the subnet mask informs us of the network versus the host portion of that address. And we've talked about binary conversion. We've also talked about classful addressing schemes, specifically class A, B, and C address ranges. We've also talked about the concept of classless addressing as opposed to those classful schemes. This is where subnetting comes into play, allowing us to create classless addressing, dividing our larger blocks of addresses into usable sub-blocks. So let's say we have only two IP addresses that need to communicate on a network segment. In this example, you'll see 192.168.1.1 and 192.168.1.2. We see our network address is 192.168.1.0 with a /24 subnet mask, or in other words, 255.255.255.0. Our IP address range only goes up to 192.168.1.254 because our broadcast address is, of course, 192.168.1.255. We talked about how to determine the broadcast address in the IP and MAC addressing video. So if you don't remember that, feel free to revisit that topic. This means that we can have 254 different hosts on this network. But in our case, we require only two. If we are to put the entire /24 range to use, we've basically wasted a lot of IP addresses. Everything from 192.168.123 all the way to 192.168.1.254 stands wasted. This is especially a problem when dealing with least public IP range. You don't want to waste a penny by having any address idle out. We can be more efficient through subnetting, creating a much more restrictive subnet mask that we are not needlessly taking up IP addresses that we are never going to use. But how do we know which subnet mask is going to work best for us? Well, there's a formula that we can use to calculate how many hosts a particular subnet mask will allow. And that formula is 2 raised to the power of h minus 2, where h is the number of zeros in the subnet mask, or in other words, the number of host bits, hence the h in the formula. Remember, the ones represent network bits in a subnet mask and the zeros represent host bits. So let's say we have the network seen below, 192.168.1.0, which by default is a class C network. But we've applied a classless subnet mask of 255.255.255.224, which is a /27 in CIDR or prefix notation. By classless address, we mean we are assigning a subnet mask other than the default class mask, which for a class C private IP address, remember, will be a /24 subnet mask. So here with our /27 mask in binary, the first 3 octets will be all ones. So anytime you see a 255 in the subnet mask, you can automatically know that that octet is going to contain all binary ones. If we use our binary table that we looked into in a previous video, we can convert the 4th octet of that subnet mask, which is the decimal 224. We can convert that to the binary number 11100000. So in this case, we have 5 zeros or 5 host bits. In other words, 2 to the 5th power is 32. This gives us 32 minus 2. Now, why do we subtract 2? Well, again, remember, we have a network address and a broadcast address already taking up 2 of the addresses in that range. So we can't assign hosts to either of those IP addresses. That's why we subtracted 2. So this comes down to 30. This tells us that a 27 subnet mask can support 30 host IP addresses. In our original example, where we have only 2 IP addresses communicating, we can use a /30 subnet mask. 30 is 255.255.255.252. Or in binary, our first 3 octets would all be ones, and the final octet would be 11111100. We have 2 zeros, meaning we have 2 host bits. So again, using our formula, we have 2 zeros. So we take 2 to the 2nd power, or 2 squared, which is 4. Then we subtract 2, which leaves us with 2. This means that a /30 subnet mask would only support 2 hosts. And again, in our original example, that's all we need. So that's one way we can use subnetting. By the way, let me show you a shortcut for finding the CIDR notation mask from the binary number. In the previous example, we know that we have two host bits in the binary equivalent of /30 or 255.255.255.252. We see that binary laid out here in the octet table, and that gives us two host bits. There are always going to be a total of 32 bits in an IPv4 subnet mask. So we subtract the host bits from the total number of bits in the subnet mask, which is 32 minus 2. This equals 30. So that tells us really quickly that we want to use a /30 subnet mask. I've also included several cheat sheets in the course resources for the subnet and host calculations for easy reference. So feel free to download those and reference them on your own. If you know how many hosts you need in the network, you can simply reference this cheat sheet and find the subnet mask in both decimal and CIDR notation. And it's going to list how many hosts will be supported by that subnet mask in order to be most efficient with your addressing.